Today's video is to prove the Pascal identity as n choose r plus n choose r minus 1 equals n plus 1 choose r, or in other words, n objects taken r at a time plus n objects taken r minus 1 at a time equals n plus 1 objects taken r at a time by left hand side. Remember that n choose r can be written as n factorial over r factorial n minus 1 n minus r factorial plus do the same pattern on the next addends. So n factorial r minus 1 factorial times n minus r minus 1 factorial. Since we have now the what we call denominators, we're going to simplify it. So bring down this. But here we can simplify the denominator as distribution method. So n minus this is negative r and this is positive 1 factorial. Now since we have the fractions, we can simplify it using the idea of LCD, or the least common denominator. But before that, we're going to do the simple logic by giving an example, such as, let's say we have here 5 factorial is equals to 5 times 4 times 3 times 2 times 1 is the same as 5 times 4 factorial. Now here, we have here r factorial, n minus r factorial, r minus 1 factorial, n minus r plus 1 factorial. In order for us to get r factorial, we simply multiply r minus 1 factorial to r. In what way? So assuming this is what we call the r factorial, and the 5 is the r, therefore we're going to multiply the r to r minus 1 to get the r factorial. So therefore, r factorial is equals to r times r minus 1 factorial. How about n minus r plus 1 factorial? Do the same patterns. So we have here n minus r plus 1 factorial is the same as, remove the factorial, so we have n minus r plus 1. Okay, that's it, the same. Here, we're going to use the factorial. Plus 1 minus 1, it becomes n minus r factorial. Therefore, applying that idea on its denominator, so to get the r factorial, r minus 1 times r. To get n minus r plus 1, we're going to multiply n minus r times n minus r plus 1. So we're going to write it here as n factorial over r factorial times n minus r factorial. To get this, we're going to multiply this as n minus r plus 1. Okay, so n minus r plus 1. Whatever you multiply here must be multiplied to its numerator. Plus, okay. Now, to get the r factorial, we're going to multiply r minus 1 factorial to r. So we have here r minus 1 factorial times r. Then copy this. Then whatever you multiply here must be multiplied to the numerator. So we have here, we have here r. We can have now the new equation as, we have here as r factorial times n minus r plus 1 factorial as our least common denominator. Then since we already get the LCD, simply do the addition on its numerator. Since n factorial times n is n factorial times n factorial times negative r is negative n factorial times r, n factorial times 1 is plus n factorial, then plus n factorial r. Then of course, simplify the numerator. So negative n factorial r plus plus n factorial r can be removed. So we have now here the remaining equation as n factorial n plus n factorial over r factorial n minus r plus 1 factorial. Then using the factoring, so factor out n factorial, so we have n factorial. Okay, to get n, we multiply it by n. To get n factorial, just add plus 1 over, at is the denominator. Then after that, we know that if we have this r factorial is just the product of factorial times this r. So this is now the r, n plus 1 is r, then n factorial is r minus 1. Definitely it becomes n plus 1 factorial. Okay, over r factorial n minus r plus 1 factorial. We can simply equate it as n plus 1 choose r, or n plus 1 objects taken r at a time.